because I think it posts it to YouTube automatically. And then it'll get like 5 to 10 views. It'll be good. We're working on the YouTube channel. All right, welcome. MALDI live stream polymer training. All right, so we got the Bruker one. I just kicked the plate out for that one. You just do that by hitting eject carrier. I typically just run the Bruker myself. We don't have a ton of room on the plate here. Maybe we should. You have a lot of samples, dude. Let me clean this plate. I'll show people how to clean the plate. So we have this plate. And then I typically train people, since you're going to be trained by yourself, on the SciX. So let's try it on the SciX with yours, but then while we're spotting, we can just spot it on the Bruker as well.
Sounds good.
And then we'll have it as a backup. So I'd say that the Bruker, more sensitive by like maybe 2,000 or 3,000 Daltons in mass range on the reflector mode. So I can see maybe like 6, 7, even 8 kilodalton things in reflector mode on here. Both of them are probably equal in linear mode. This guy, I don't know, the pusher's not as strong, I guess. I probably maybe out to 3,000 or 4,000 I can see. This one's kind of easier to use for walk-up. All right, so it's a hands-on training. Hey, we got 2 people, there we go. Okay, so hands-on training. We're gonna train on the ABI SciX instrument right here. Okay, so what I tell everybody is we got ourselves a British instrument and we have ourselves a German instrument. The German instruments, the Germans really love like physical gears and latches. Very mechanical. And you'll see on that plate in there, it's connected by like a cantilever system that locks it in position. The British have chosen magnets. Pretty genius. Much easier. So anyways, I'm gonna put this guy here to show everybody. All right, so we have a holder, right, and a plate. The plate fits into the holder like a puzzle piece, face up, so the spot's up, right, and then into the notch in the bottom left corner. And then you want it flat and flush in the holder, not up on the lip like that. So you definitely don't want it up on the lip like this. You want it flat and flush in the holder, okay? And so guys, it's a hands-on training, so go ahead and just do it. There's 2 targets. And the undergrad's supposed to clean. These, and so just grab one that looks pretty clean. And so then you can see this looks just like the same shape, but because it has mechanical elements, this is definitely like a holder for the Bruker.
I see.
Yeah.
That's the only one for that.
Yeah. So only the magnetic holder with these plate toppers, these 384 toppers, are for the SciX instrument. Yep. All right. So then we'll just use that plate right there. You can bring it, just keep it in. Yep.
Yeah.
All right. And so then we're going to be spotting in here. Okay, so you have your own Pipetteman spotter.
Yes.
How fast did somebody steal it? Oh my God. Oh, there it is. Okay. Woo. Okay. So this is, not to plug it because I don't make any money off of it, but this is the $28 Amazon Pipetteman.
Really?
Can't get cheaper than this. This is literally the cheapest product on Amazon. That's right here. It's beautiful. It works great. I've been loving it. So anyways, I spot typically 1 to 1.5 microliters. It even comes with these little nubby things, different colored nubby things. I'm telling you, I don't think Gilson's giving you those. So I'll do like 1.2, 1.3, right? And it takes these smaller tips in the red box, okay? Everything, I typically pipette matrix first and then sample into the wet matrix, let them co-crystallize together. So these guys are mainly polymer guys here. And so we're going to be doing, I like using DCTB. You like using, great for polymers, right?
Yeah.
Okay, so I have DCTB here in this tiny little bottle. Do you make yours up in THF?
Chloroform.
Chloroform, okay. So MALDI, a nice little, let me flip it around so you guys can see. Nice little bottle of jank chloroform there. I love that. That's good stuff. You traveled that in the car, I'm assuming. Yeah, for sure. So the rule with MALDI is you can use any solvent which dissolves your stuff. For you, it doesn't dissolve. But the only rule is it has to dry, because this is a vacuum system, and it has to go into the vacuum to like -7 torr. And so if you're in DMF, you unfortunately could have some problems. Typically, if I dilute out like DMFs or DMSO or like glycerol, sometimes you have people have glycerol, to like 0.1%, it will like dry inside the matrix crystals enough that you can pump it down. It won't even let it in to the instrument if it doesn't pump down. Like it is a lock. It's like a submarine. Yeah, there's like a lock to get in, and so you won't get in if it doesn't dry. So anyways, you guys can make up your sample. I typically make up the DCTB, which is right here. It's expensive, so I just take a couple little crystals out of there and I'll dissolve it in whatever solvent you want to. I'm gonna use THF, and then I spot it directly. Are you here for the MALDI training?
Yeah.
Oh, fantastic! You've only missed a little bit, and I'm live streaming it. I hope you guys don't mind that I'm live streaming.
Great.
What type of sample are you guys?
We have it's a protein.
Okay.
The subunit molecular weight is 15 kilodaltons.
15.
Right.
Okay. That should be fine with just regular CHCA matrix.
Oh, I use the.
Or cinepinic acid, either one.
Yeah, I use the cinepinic.
Yeah, so there is cinepinic acid. Okay, so here's another thing. Let me just show you guys really quick the things you missed, okay? Put this guy down. I'm not an avid live streamer, so it's gonna be janky here. Okay, so it's a hands-on training, guys, okay? So for the SciEx instrument, which I'm training you on, right there, the plates look like this. They have a topper, magnetic topper. It's not like your Bruker one there. That is the nice Bruker right there.
Okay.
And
I actually have one of those.
that's awesome.
But it doesn't have any protein on it.
We can take it off of that plate if it's already spotted,
Yeah.
and put it onto this plate. Just
Awesome.
dissolve it.
That would be
I
great.
typically dissolve it in new matrix and then re-spot it over and transfer
Okay.
it. Okay.
Yeah.
So with these plates, you want to put them in like a puzzle piece, right? So you want
Right.
the 3D4 side up. You want it to go into the corner like a puzzle piece here, and then you want it to not be up on a lip or anything like that. You want it to be flat and flush in the holder. Okay.
Okay.
All right, and then what I was telling them is I typically spot 1 microliter of matrix and then 1 microliter of sample into the wet matrix so they co-crystallize together. For yours, I would just
That's-
put a spotted matrix on top and then go ahead and transfer it.
Yep.
Okay, so the other thing is, okay, so let's flip this around. Okay,
You guys bring samples?
yeah, so they're polymers, guys. So we're gonna do a little. It's pretty good. It's pretty similar. We'll probably have to go to linear mode for you guys, anyways.
Yeah.
Potentially, your stuff's
It's
big.
gotta be linear.
Linear. Okay, cool. And then we could put yours onto the Bruker as well, if there's enough. I just don't have that holder.
Yeah.
I have a big Bruker.
Ah,
Yeah,
okay.
I like that really big
Alright.
one.
This is actually.
It takes this.
Okay.
Takes this.
Yeah.
But after this training, let me show you the QTOF. I typically run all proteins in the QTOF now, just because it's
Okay.
like faster and easier.
Yeah.
It is more expensive though. So anyways, that's the Bruker plate I have that we can transfer to if we want. Okay, so matrices. I typically have matrices already made up over here. If they look really crystallized and old, then you can make them up again. Okay, my signature is 2 dots. It's easy to forge. So, but nobody's been forging it. So if there's 2 dots on it and it's CHCA, I made up the CHCA. There's DHB and there's SA that looks really terrible. So I probably would make up fresh SA. And then over here in the multi-matrix cabinet, you should have everything you need down in this like region here of all the different matrices. And then we should have pipettement, obviously, and pipette tips. This is the one I've been spotting with, this $28 Amazon pipettement. So if you like it,
I've been buying so much.
they're so good. I'm telling you, like for $28, if it breaks, you just throw it in the trash and get yourself another one.
I got a centrifuge.
So good. You have to send me the link of which centrifuge you got, because I'm doing like a high school outreach class.
Oh, the MC, the one, it can do 50 mil tubes.
Oh yeah, you have to send me a link or something.
Yeah.
Yeah, so I know. Okay, and then there is acetonitrile with 0.1% TFA, plain acetonitrile, and then there should be 0.1% TFA and water floating around in here somewhere, so you guys can spot.
And then are we allowed to just use the reagents?
Yeah.
If we come, okay.
Yep. Yeah. So here you can
I
use
actually
anything.
have everything in my lab.
You can spot it there in your lab and bring it over here, or a lot of people just come here and spot it. And then also, if you're going to use this one a lot, if you don't have these plates, I can give you a plate. I have a lot of them.
Okay.
Yeah.
Yeah, I
So
have one
some
like that, yeah.
some people like spot them and then bring the plate over. Yeah.
Yeah, that's. The
Where you guys live? How far away?
That's site 2.
Oh,
That's site 1.
that's
site
ah.
1. Sorry.
You're fine. At least you're not med campus.
No.
Yeah. Or UCLA.
Are you guys from UCLA?
He's UCLA. He's even closer. Yeah.
Okay.
All right. So I'm gonna clean this target here. Since you guys seem to have things ready, you can go ahead and you could use acetonitrile, water, or something, just pull off and transfer the spot. And then there's room on here for you to start spotting yours. Do you already have your matrix made up?
The matrix is made. The samples, I haven't put them in the tubes yet.
So whenever you're ready, you can probably go first for spotting.
Okay.
Yeah.
And then
What we can is you can,
and then you will be.
just draw it.
How much sample do you got?
Some
Well,
of
What do you got?
2 megs.
And we're doing a time course for your stuff.
Yeah, I have 2 different things. I have the one that I can do a time course with.
And then you have the one that's like
Just a solid.
Yeah, so we'll see you last.
Okay.
I'll help you out. I'll spot
Okay.
yours, and
Okay,
then we'll
thank
try
you.
it. Since your stuff is like insoluble in everything, we'll have some
So
things. All
we
right.
should drop a microliter
Oh, it's a
of
nice little
the,
thing.
this has the SA on it.
I typically would use CHCA. So what I would say is I would take a spot of this CHCA, like 1 microliter, and let it dissolve your spot, and then just transfer it to a spot here.
Okay.
Okay, and then the most important thing, guys, is write down where you spotted it,
Yeah, I got
because
it.
it's a you're a smaller grid. This is a 384 grid.
Yeah.
Yeah, I never find it, and then I have to go bring it out of the instrument.
It's not complete.
Okay, so yeah, go ahead. You guys can get started. I'm gonna clean this one off for everybody.
All right.
I'll bring these guys with me.
Respond.
Morning. Sorry, it's gonna be mayhem. I'll try to respond to questions, but welcome to MALDI training. I don't have my solvent bottle, so we're gonna clean this MALDI plate now. I guess that's the point of a live stream, is it's wild and crazy. All right, so we have a methanol squirt bottle. We have an isopropanol squirt bottle. All right. Getting gloves. If I had Horace here, I could have him hold the camera, but we are holding it ourselves today. All right. All right, awesome. Glad you're enjoying it. Okay, so now I'm gonna go get. I'm running around. All right, so we got our solvent bottles, we got our MALDI plate. We're gonna go ahead and wash this guy. Oh, last thing. I typically use, instead of like paper towels or something, I'm using these things called Technicloth. Let's see. You see, it's kind of mirrored. Technicloth TX609s. These are clean room fiberless wipes. They're like expensive woven cloth. So I typically use those. I know they're clean. They're for clean rooms. They're super good. Never have any problems with polymer contamination. If I use these Technicloth wipes. You know, I used to work in a clean room back in the day. Way back in the day. And, all right, so there we go. So, what we do is I'm going to turn on the MilQ system. I guess we can face me like this. Or like maybe like this. There we go. All right, so I turn on the MilQ system. And then I will spray it down with some methanol. And then I will spray it down with some isopropanol. Alright, methanol, isopropanol, and then scrub with the Technicloth. And now it's basically clean. So then I want to like recondition the surface once it's all clean. And I'll usually spray it with methanol. And then I will spray it with water. And then the thing you want really is you want it to kind of like all the water to flow off of it, kind of stick to the spaces there. And then I'm gonna kind of gives it some sort of, you know, hydrophobicity here, so it doesn't spread across the whole target. Find if you dry it right out of methanol, then you see the spots spread a lot more. We'll put the final water on the surface. All right. Typically, I disconnect it from the holder. This holder too. That. Alright, let's go check out what everybody else is doing here. Alright. There we go.
are still wet.
Okay. Sounds good.
All right, and so you're gonna go. Are you
they
gonna
just-
take forever, or
It might take forever. So
why
maybe
don't
we can
you?
just-
We're gonna do the training. Why don't you just spot like 2 or 3? Because you have time today to just continue spotting.
Yeah, I'll spot 2.
Yeah, just spot like a couple to see if they work,
Sounds good.
and then we'll. You just have those 2 samples.
We have 3.
3, perfect. And then we'll do your mystery stuff.
Okay.
I think I'm gonna go THF.
Okay.
I mean, it's the best option, really.
That sounds good.
Yeah. I mean, what's the worst that can happen? It just doesn't work. And then just from here still, you can spot it on the Bruker.
Sounds good.
And then you could probably just get stuff that you're more
So
comfortable
spot it
with.
here first, just for the training.
Yeah, yeah. Well, I mean, it could work really well over there, to tell you the truth. Sometimes
You said the
People
linear
like it.
mode's the same, so I think it will.
linear mode's kind of the same. Some reason I like the flatness on the SciX better. Like, I think it's just the way it holds the target. It sits a lot flatter. So sometimes I get better accuracy.
Don't they have mass spec at UCLA?
Broken.
The MALDI,
Wow, no.
The life of MALDI. It's always down.
so sad. It's been down for 4 out of the 5 years.
Jeez.
What?
See, that goes by what I was saying. They're always down.
The chemistry department? Yes.
Yes.
Oh, man.
I know.
Yeah, I came down
Caltech's.
here like 2 years ago.
Yeah, and Caltech's went down too. And so I have Caltech people coming in. But yeah. Some of our stuff's broken, so you know, that's how it is.
And then how do we do, sorry, this is Michael.
Hey.
I'm Melanie Coker, I'm a faculty member in
Yeah.
MUB.
Yeah.
And we met, I think.
Yeah, we've met before. Yeah.
So how do we sign up for COP?
There's no, we don't do, it's like first come, first serve. It's just walk
Okay.
up. There's not enough traffic that you really
It
need.
doesn't take that long to get there.
Yeah, really, and since it's spotting is separate, like we don't bill you for for spotting time, just instrument time. So it's like most of the people we have are synthetic peptide chemists, and they're like in and out, like they just don't care. Yeah,
Yeah.
they don't even save their data.
Right.
They're literally fraction checking, and they're like, there it is, fraction 7,
Right.
leave, and
Yeah.
then they're like done.
Yeah,
Yeah.
so we're looking for post-translational modification of protein.
Okay, what kind of PTM?
And it's it's produced in E. coli, so we're
Yeah.
using methionine aminopeptidase to remove the N-terminal net.
Okay.
We absolutely have to have the N-terminal net off, and so it's 150 Daltons on top of.
You'll get it on the Bruker.
Okay.
I typically like to do that work on the Ziva, on the QTOF.
Okay. Yeah.
I think it's just better.
Yeah.
Like in all ways. Yeah.
Yeah. So
Like it's accurate to 1 Dalton. Like it
Right.
will be right.
Yeah.
Yeah. And then
Yeah.
its sensitivity. Like the problem with MALDI is like, and you can get around it if you spot your protein. Like do a I'll show it on his. How to do a serial dilution on plate when you spot the MALDI, so you see it at different concentrations.
Right.
But that's the way people like mask impurities a lot of times. Is they'll spot it at high concentration.
Yeah.
And then they are like, oh, it's good. But the linear dynamic range on MALDI sucks. It's like
Right.
maybe like 10x linear dynamic range if you're like really trying. So you think it's clean, and then you run on the QTOF, and it's like not even close. And so if you're really worried about there being no methionine left, then I would run it on the QTOF and like
Okay.
monitor the reaction.
That's not this training.
No, and typically for that, like before I even train you guys, you just bring a sample by,
Okay.
and I can help you run it. For a 15 kilodalton protein, I'd say like 0.02 mgs per mil. And it doesn't, as long as it's not in like SDS detergent, you can leave it in sample buffer. It desalts it. It's like a protein desalting column method.
Okay.
It's 5 minutes. People use it all the time on the Ziva. I'll show you. It's quick. It's just like desalts it in 2 minutes. Everything goes to waste, and then it just runs off
So
the
you just
protein.
inject it.
It's designed for conjugation chemists, right? So
Okay.
they don't want their proteins to separate.
Yeah.
They want to just have everything in one peak so they can do a deconvolution on the blob and then get their conjugation ratios, and then they're done.
Yeah.
And so it's nice.
Okay.
Yeah.
Yeah. And then that sounds.
I've had the same thing, like people are like, oh, I'll do it cheaper because I'm just doing a thrombing cleavage. And you look at it over here and you're like, it's kind of blobby, like maybe did I get it? And I'm like, just put it on the high res. Yeah.
Okay. So then for getting time on the QTOF is.
Again, it's a walk up.
Okay.
It's really cool. I'll show you how I set up the QTOFs. It's like, again, it's a training, it's quick training, so it's good for you to learn how to use it. But there's stock methods at the top of the sample list. So you just go up and grab the protein method, put your sample into the auto sampler, and just run it, and then I'll show you how to do the data processing. It's quick. The disadvantage is it's $20 a run on the QTOF.
We're not gonna have that many.
Yeah, so you don't have that many samples, so it's not like huge. Might as well get really good publication quality data.
Yeah.
All right, and so then we'll spot this guy next, later. All right, let me. So what do you got for me here? Is it this thing or? Here, Joseph, you don't want to be in it. I can. Pretty decent. Okay. I started putting the YouTube lives up on YouTube, and it seems like people are watching them. Not like 100 people are watching them, but how many people are doing MALDI?
Oh, it's cool. It's cool.
MALDI training consistently. Yeah. So yeah, it's I did like a live stream from like the UCI extension farm, and there was a little bit more people on it, but there are some people.
Yeah.
And this guy says it's an entertaining and informative. So there we go.
Okay.
So this guy, we got one person. One person's enough.
Rave review.
Rave review. I'm just so impressed by this $20 pipette mint off of Amazon.
Yeah.
Like, come on. Like, this is great for me. You know how many pipette mint I lose a year since it's open access and people just use it? Like, I come in every day and, like, probably 4 or 5 times a year, like, it will be severed. The plastic snapped. Like, yeah, they're like hitting it with like as hard as they possibly can, and then they crack it. And then we have like external access doors, right? So you can come like 24 hours a day and work here. And so it's always like somebody probably frustrated in the middle of the night shatters it. Okay, so you have a sample?
Yeah, so it's the solid in the back of the bottle of this.
Okay.
Yeah.
Okay, so I'm gonna go.
Yeah.
Oh no, did they seal my bottle of THF? Oh, here it is. Yes. THF has gotten really dusty with the THF.
Really?
Yeah. Because if it's expired and you don't have an inhibitor, they think you're going to blow yourself up with
yeah.
peroxide crystals.
Peroxide.
But look,
There's no crystals, yeah.
safe.
Yeah, I got dinged because my isopropanol wasn't marked with the date received.
You're like, when do we have to worry about isopropanol peroxides? Like,
Right.
ever. Like, if they dropped off a 5-gallon drum during COVID, I'm not, like, worrying about... Like, same with the ether. Like, I've never had to worry about ethyl ether peroxides. And I come to California, and they're like, oh, yeah, we got...
I can move some of this stuff just to
Okay,
some
yeah,
space.
just, yeah, let's do it. Okay, so let's do... So this is you, and this is you, or this
No,
is
they're the
this?
same thing.
Same thing?
Just that one has more in it. So.
Okay. So for DCTB, the polymer matrix, I take like a really tiny amount with a pipette tip. Okay. I'm gonna do DCTB for you. Yeah, I don't even weigh it out. I don't do anything mathematical for MALDI, I just throw it in there. Alright, and then I go like maybe 20 microliters or so of THF. Alright, a little pinch of the matrix, THF. Hopefully it's a little yellow. For CHCA, make it upsaturated so it really doesn't matter. Same thing with cinnamonic acid. And so yeah, just a little bit there. And then we're gonna go throw in maybe like 100 microliters or so.
I'll be right back.
The other thing that I find really funny, instead of giving me a real hood, like I wasn't the first person doing MALDI here. This was here when I got here. They gave me a laminar flow hood. I don't understand. This is here when I got here. This was the MALDI station. These instruments were here. I was hired like 8 years ago. This existed before my time.
That's exactly the wrong hood to use.
Everything about this is wrong. You're like, what are we protecting from the sample, guys? So yeah, I don't understand
So
it.
the normal hoods pull the air out. The laminar flow.
Blows it in your face.
It blows it in your face. So if you're working with a sample and you don't want it to get contaminated.
All right, so I'm gonna go in K for you. Can you remember K?
Okay.
You
Yeah.
open the tubes in there, and then it filters the air.
And so what I'm going to do is I'm going to spot it a bunch of times, right? So what I like to do is I like to do like a serial dilution plate kind of.
Bacteria and viruses.
But for yours it's going to be tough because we don't even know if we dissolve this sample or not, you know?
It probably didn't.
I'm just going to like assume, oh, you know, it's like definitely something happened to it.
Yeah.
We've got something going. All right, so I'm going to go ahead and like mix it in. Maybe we'll even get like a little chunk, you never know. So I'm spotting it 4 times.
You don't want to be breathing this nitrile.
Or the THF.
Or anything you have like chlorophyll.
Yeah, that's it.
But, okay, and then I'm going to put another, on 2 of them, I like to do like a sandwich approach. So I'll do like a spot of matrix, a spot of sample, and then a spot of matrix again. Okay? So 2 of them I sandwich, 2 of them I didn't sandwich. Okay, so if you ever have a spot that won't dry, or you're impatient and you don't want to wait for water to dry, there's the heat gun over here. Okay, and so down is hot. Try not to like scorch it.
Right.
But I just give it a little dry here. That looks good. So everyone remembers where they put stuff?
Yeah, we are 16, 17, 18,
A.
those 3.
You got yours, Joseph?
Yeah.
All right. And then yours, I think I got like a couple chunks on there.
Cool.
I mean, that's the thing with MALDI is you can't put chunks on there. So like, you know.
Great.
Yeah.
I'll take chunks.
You can put chunks on there. Okay, so this is the next part of the hands-on training. There is like a how to load a MALDI plate YouTube video there that's pretty ancient. Okay, so do you mind holding that real quick for me while I just show people how to do this? Okay, so loading the plate is the most important thing because this is how you'll break the instrument. Like everybody who's broken the instrument and I've had to fix it is because they loaded the plate improperly, okay? So we want face up. That's the first thing. I've had people put it in upside down. Don't put it in upside down. Laser fires from the top. That shoots the sample with the laser. Okay. It's kind of like a hydraulic Tesla door that you gotta hold it open. Okay? I like to use my left hand. So it says on here, it says load plate against pins, and it shows that the notch is in the bottom left corner. It also shows you not to put the plate on this side. That's where it ejects the plate. It's just like a lazy Susan situation. Okay? So notch in the bottom left corner, face up, flush against the pin. So that's the most common mistake, and then it will drop it. You'll see how the robot arms grab it. That's the important part. Also, if you go too far back, it'll catch on this lip. You can just kind of like lift it up. Okay, so just everybody give it a practice really quick. Loading it against the pins. I'm not going to you, so it's not, no pressure. No pressure. Yep, exactly correct. Perfect, yep. Yep. Very good. Perfect. Ever since I started doing hands-on training, have had very, very few mistakes. So it's good to do it. Perfect. All right, so you're in. All right. So now on to the ancient computer. You do not need to use the PlayStation controller. You can, but I don't. It's hard to publish that I acquired data with PlayStation controller. All right. Don't make fun of me, guys, on the internet. I know, it's Windows XP. If you're in Windows XP, that is mandatory. All right, so if you're not familiar with Windows XP, you got the start menu, you're in the top series controller software. That is also already open. You can see that it's open down here. The first command you need to do, notice we're gonna do everything from this file toolbar here, but when you go to things, we're gonna go to plate, load plate. You'll start seeing shortcut icons that you can use from up on the toolbar here. So you could eventually just do those. Load plate. We're in John's project. Okay. Any of these 3D4 OptiTop plates are fine. So it doesn't matter which one you select. And then you hit select and load. The reason it needs to be dry is it's going to pump down this chamber before it pulls it into the instrument. So I use a scroll pump. Like, I'm kind of weird. Nobody else uses scroll pumps. So that was the sound of a scroll pump pulling the vacuum, right? If it sounds different than that, let me know. There's something horrendously wrong. So I've had people put the plate in up on like a peg and the door isn't closed. So it's just making a horrible sucking air noise. Also, I don't repair my scroll pumps until they fail. So like I'm a repair tip seals when failed. Yeah. But yeah, I'll show these guys. That's what the scroll pump looks like right there.
Oh, yeah.
And yeah, it's a dream. Once you put scroll pumps on them, like, oh gosh, it's just a dream. I did it to the Bruker too. Look, the Bruker guy came here and he's like, what on earth? I'm like, have you ever seen anyone do it before? He's like, no.
How low does it
Well,
pull down to?
it gets a lot lower, you know? So I'm down at like, I'm almost, like I've gotten the Bruker down to almost -9 torr. And this guy's down low -8s. So, I mean, you want lower the vacuum, better your data.
Yeah.
I don't know where the leak is on this one too. I don't know where it is. It's up in the front solenoids, maybe in the front end. But I had Ultraflex. It was just like this one at my old university in Kansas.
Plate.
Yeah, see the plate went in? No, it's navigating on.
It's standing there.
The one in Kansas, I was like checking seals, and I got it. It was consistently in like the -9s. It's like you get reflector mode to work out to maybe 15,000 if you get down to -9. And then your approaching would look really good over here. All right. Here we go. Yeah, so the PlayStation controller, you have to put it into manual acquisition mode, and then I guess you can. I've legitimately, it's covered in dust. I've never tried. It's kind of sad, but I've never done it. Okay, so we're already in linear mode here. So we're in linear mid. So this is like a tab system. The methods that are active are the ones that are green, and there's already a lot of methods open. So what I typically teach people first, so our plate screen, we have linear mid, the processing method, and the laser method that are active. So I think linear mid is kind of like where we want to be. So what I'm going to do is I'm going to set the reflector mode methods as active. So that's the set as active button if you hover over it. And then I'm going to close things so you guys can see how we do it from scratch. Okay. So if the linear mid methods are not open, or linear high, you can use linear high as well. You want to go to File, Open, and so we're going to be opening an acquisition method and we're going to open a processing method. I don't use interpretation methods. You want to make sure that your two methods here match. So you don't want to do like reflector one and linear another. You want to match them, okay? So acquisition method, and here you'll see we have a bunch of methods. There's both positive and negative mode. Most people are positive, but you polymer guys are weird, so you don't know. Especially your polymer super weird. Maybe it will be negative. Sulfurs are weird, that's the thing. Oh man, are they weird. Okay, so we're gonna go with linear mid positive, right? So linear mid mass positive, the regular method there is gonna open it. And notice it's not automatically green. So to set it as green, you can either use a shortcut here, it says set as active, or if you forget, you can go to File, Set as Active Acquisition Method. And then you wanna open your corresponding processing method. In processing, there's not negative or positive. There's just default or internally calibrated. So just the regular default linear mid-mass. And you're gonna set that as active as well. You don't need to do anything in the processing tab. The only thing you need to do is change the mass range in your linear tab here. And this actually is a pretty good mass range for you guys. Maybe we'll go a little bit lower. So like 20 kilodaltons or so.
Okay.
And then the focus mass, as long as it's within your range, it should be fine. Or maybe let's go for you guys, let's go up to 30 kilowatts. It doesn't really matter, right? And then you're 15K, okay? Okay, so that's the first thing I'm gonna have you guys practice. You can go ahead and just practice like pretend opening up the method so you know how to do it. The next thing I'm gonna have you do is, what's the spot that you're in?
16, 17, 18.
Okay, so to navigate, you can either do this positional pull down tab here and go up to 16, 17A.
Okay.
Or you can hover over the position on the plate and click on it and move to the well directly. The other thing I like to teach people is how to walk without shooting the laser. So like sometimes the spot's dry outside the circle here. You want to double left click. If you double left click, you can walk without shooting the laser, okay? All right. And then the next thing, if once you have everything set, your laser intensity, you can move it down a little bit if you want. Like sometimes I'll start around 7,200 laser power or so. You have your method set, you have your mass range set, and you're in the right location. you're going to left click, holding down the left click button, and drag to make a box. And it's going to random walk inside that box and acquire your data, okay?
Okay.
The first shot of the day, box of the day, in any mode, positive or negative mode, linear or reflector mode, it's going to have to ramp the entire beam path, right?
Right.
That could take like a minute for these to turn green. So
Okay.
acquire all of your data in one mode before you switch to try another mode and things like that. The longest time, as you saw, is to take a target in and out. So spot everything you can possibly think of, all different concentrations, then put the target in, then acquire all in one mode and try to get it working. Then if you want to try a different mode, you can go ahead and switch and try. Just don't be switching back and forth much. And so then once that's all hard, so I'm gonna let you, yep,
Oh, you can see the.
yep, see the laser,
You can see the laser.
you can see it shooting.
It's, and
And so
moving around.
hopefully we'll find your protein, but at the moment I'm not seeing anything out in the range, but a lot of disappointment in MALDI.
Yeah.
Okay, so anyways, I'll let you go ahead and do it now.
Okay, Michael, do you wanna?
Yeah, go ahead, because you guys don't have that many spots. And then just let you get familiar. So the things to do,
So try.
so do the pretend opening the method, file, open, acquisition method. And then let's have you open linear high mass, actually, positive there. Open, since they're both linear high positive, it won't take long to switch. And then open the processing method for it. So file, open, processing method, and then it's gonna be the linear high mass default. Yep. And then set that one as active as well. You can use the shortcut there. Perfect, yep. So now just go to the laser tab there. Oh, go back to your linear high one, yep. And set that as active. Yep. So in that one you're gonna change the mass range, but that mass range looks, yeah, put it to 30,000 maybe. One less zero, that's standard, yep. And then that 22 is fine. So go ahead and now navigate to your spot by hovering over wherever you guys are. Okay, it's perfect. Double left click and practice walking around. Yep. All right, so now left click and drag to make a box. And it should fire the laser in a second here.
So after you drag the box, it automatically starts.
Should automatically shoot the laser. I guess there's a little difference in voltage between these two methods.
Yeah, once this box turns green, it'll start firing?
Yep. And then what we can do, if we still don't see it, you can go up and increase the laser intensity. The double arrows will move it up 100 at a time. Yep, so there it's firing. We're not seeing it still. Could be too salty. So go to the double arrows and go up maybe like 400 or 500.
We did zip tip the protein.
Oh, well, that should be good then.
Yeah.
Maybe it didn't transfer well. Let's see.
It was like a pretty diluted
It
one
was
when
very.
it started.
This
Yeah.
one was very dilute. Yeah. The next one over 18 is more concentrated.
Yeah, this is 18.
Oh, this is 18.
Yeah.
All right then.
What you can do, sometimes low mass suppresses high mass, so maybe bring this up to like 5,000. And then go ahead and shoot it again. You can go up to a little bit higher laser power, maybe 77, and that's about it.
Yeah.
And then we can always try spotting it onto the Bruker. Try the lower concentration ones as well, just in case.
Alright.
All right. Well, sorry guys.
Yeah.
We'll try it on. We can put it on the Bruker too potentially, but yeah. All right. All right. So you want to just go get a go for it? You're already in linear, so give it a go. So yeah, navigate to the spot.
Loaded, but I just.
Yeah. So you want to? Yeah, you can practice it really quick. You guys want to come back with the protein? You don't need to zip tip it or anything. You can just come back with the protein this afternoon, and we can just run it on the Q talk.
Oh yeah.
You want to do that?
I can come back. I leave it at 5.
Oh, okay.
I'll be back around like 2:33, something like that. Yeah.
Okay, 3 o'clock. We'll bring the sample back. Okay.
And then yeah, you're good. So the only thing that you missed in training is to eject the plate at the end. You're just going to go to plate, eject plate, and then it'll give you a prompt and say, do you want to eject the plate? And you hit OK, and then wait for the plate to come out onto the left side here. the vacuum, there'll be a little vacuum thing again where it's releasing the pressure from in there. And as soon as you can open this door, and the vacuum releases, you just take the target out and put it back onto the area over there, and that's it. Okay?
Okay, and so the protein concentration is about
0.05 to 0.02 mg per mil. You can bring it over more concentrated and we can dilute it here. But for 15K proteins, that should be fine.
okay, thank you.
Yep.
All right, we'll see you this afternoon.
All right.
So I'm gonna set the mid active, right?
Yep, set the mid as active,
And then
set the linear mid processing as active. Yep.
and then probably doesn't need to be this high.
Yep, and then
Change this to somewhere in the middle.
somewhere in the middle. It just has to be within the range.
Okay.
Yep. And then navigate to your location. You waiting for me?
Yeah.
What's up?
Just wanted to talk to you about some protein digest I want to try.
Okay.
I want to do it on TEF protease and Rachel's gamma S. human
Okay.
gamma S.
That looks good.
Yeah.
And it's,
Did you just get anything?
Oh no, it looks like a thick sample.
Oh yeah, it looks like.
That's it, right? Just
Yeah.
plastic.
Yep. Sorry, let me just make sure he gets it. Okay.
I
have to order more trips in. But
Okay.
yeah, but maybe next week.
Okay.
Yeah, let me order some.
That's why it looks different.
I might be able to find some, or do you prefer?
I like this Pro Mega Trips in Gold.
Okay.
But what's the idea? Just to map them?
Well, I really want to look at the N-terminus.
Okay.
I think there's some fishy stuff with miscleavage going on
Oh,
at
yeah.
N-terminus with
Okay.
with
Did you
Tab
see a
and-
blast?
Yeah, tabs being weird. Yeah.
Oh, that's
Yeah.
sweet.
And so,
Oh man, look at this. Hold on, let me flip it around. Let's show you guys. Yeah, so that's what a polymer looks like. It looks like you got your thing worked out. So
Yeah.
that actually looks really good.
Nah, it does.
So I didn't show them, but the other thing you can do here is you can hit that clear sum button, that eraser sum one.
This one?
Yep. And then you want to click back on the top spectra, and then you can add that into the accumulated spectra.
Awesome.
And so if you want to do an accumulated spectra a few times, you can do that. Whichever one you're clicked on, whichever one is red, that's the one you can save. So then you would just go to Spectrum, save Spectrum to file, the first one there. And then you can go navigate up, and up, and up, and then go ahead and make your group a folder.
I don't already have
Well, no, make your new group a folder. It's fine.
it. No, right here.
Oh, yeah.
Yeah.
Sweet. Yeah, and then save it in your folder however you want. Well, at least something works. Look at that, guys. We analyzed the polymer. There's nobody on the live stream anymore.
which
So-
polymer is this?
I don't know. It's his weird top secret polymer.
Polyoxazolene. Yeah. It's a surfactant. It's a lot of
Cool.
polymer.
Oh, it should work well then. Yeah.
Yeah.
Cool. All right. Good.
Did you want to try your sample? Sure. Yeah. Yeah.
Yeah, because you're gonna have to spot a ton of them, right?
Yeah, I have
Yeah, I
one.
mean, you might as well just do it on here, I guess.
Which one?
Do you want to do all of them on here, or you want to do it on the Bruker? Probably be easier if you do it on here,
Yeah.
because then I don't have to do it for you. So
Yeah,
easier for me.
Yeah. No, that works. And you just trained me on it.
Yeah, and then you'll get the memory of doing it, and then if you need to come back, you can do it yourself.
So it sums 4,000 shots per acquisition.
Yeah,
How many would you say is a good range to?
I think that's good. I mean, as long as you have good intense signal like that, I think you're good. Yeah. I typically don't see any advantage to adding them into accumulated spectra, because every now and again they'll get shifted and you'll get weird split peaks, and you get so like it's sometimes not worth it. Yeah. So you probably have the same kind of method. Like I would just use the exact same thing for your area.
Same matrix.
Same matrix, same polymer. Go to the laser one for look for the mass range. Yep. Yep. That one right there. And so we can go bigger, but I don't think we're going to see bigger than that. But we'll see what happens.
So do I just?
Yeah, just left click box.
I don't see nothing.
Maybe that's not nothing. Let's see. Go to the next one. So let's keep. We have 4 of them, so let's see if they're different. Sorry, I'm just trying to finish this up here, and these guys will be at least trained. So that's they're both sandwiched. So go to the next one. Let's see if the next one's maybe not sandwiched. And you can just move by clicking on the surface there too.
Oh,
Yeah. And then, MALDI is like super non-uniform, especially for yours, which has got chunks in it. So you can hunch around, double left click and walk around and shoot different areas. I think in the fourth spot, I actually saw like a physical chunk of your plastic.
Okay.
Yeah. So try double left clicking and walking around a little bit. Yeah, do that first. Maybe it's really big. I don't know. Try double left clicking and walking around.
Like.
Yeah, double left click. Just don't drag, just click. Yep. There you go. Go to the edge.
Okay.
Yeah. Shoot the edge. Shoot the edge is the spot.
It really is an art. You gotta find the perfect.
Yeah, you gotta find the perfect spot. I should flip you guys around so you can see. All right, so yeah, this is what like hunting and pecking. You know, MALDI is very non-uniform, and so yeah, I would just like start, and specifically the edge. Like it's kind of like drawing like a coffee ring, you know. Okay, then for yours, since we don't really know the range, why don't you go up to 100,000?
Okay.
Yeah, it doesn't hurt to go bigger. Just add an extra 0. That shouldn't bother anybody. Let's just do that.
Okay.
Yeah.
Let's try the middle.
Yeah, try the middle again. I thought that's where the chunk was. Maybe you just have like the thing down low kind of looks like a polymer. That's the thing. So the really tiny stuff kind of looks like a polymer.
Like this?
Yeah. Like the really small stuff down there has like the look of a polymer distribution.
Yeah.
Why don't
down here?
Yeah. So why don't you do the opposite? Why don't you bring this down to 100 and that down to like 2,000 or something, and then put your focus mass at 1,000, and then go ahead and yeah, just 1,000.
There you go.
Yeah, go ahead and shoot it again.
Okay.
Let's see if there's any anything going on. All right, too low. Let's go 400 is the low end. Let's get rid of some of that small stuff. All right, and you can shoot it again. All right. Maybe, but I don't think so.
Doesn't look like a polymer.
It doesn't look like a polymer.
But the distance between the spots should be like 142.
Yeah, so that's why I was checking down low, because your stuff's really insoluble. I would even do it one more time, like maybe go to like 700 or 800.
700?
But my guess is we just didn't dissolve it, and so you could try some other stuff.
Okay. I'll try. Yeah. That's fine. I think
See?
there's nothing there, yeah.
Do you need to run something on here?
Later, but I have a question. It says inlet not ready on the.
Zevo?
Yeah.
We have gas. Let me go check. Yeah, it doesn't look good. So anyways, when you're done, you can mess around with it a little bit more and see if you get anything else, but it doesn't
Yeah.
look that good.
No, it looks terrible.
It looks terrible. We'll try again. All right. So go ahead and just do plate. When it's done shooting, yeah, when it's done shooting here, do plate, eject plate, and okay. All right. And then it'll kick the plate out over there. And once the pressure releases, you guys can take the plate out, and then you can just start spotting.
Okay.
And
If I wanted to wipe it, just wipe it.
you don't need to wipe it. There's probably a lot of room on it. And then this plate's clean, really clean too.
Okay, sounds good.
Yeah. I'll take my gloves off. So for you, yeah. So really quick for you, yeah.
A protocol, right?
Yeah, there's the protocol right there. Whoa, I zoomed in on my face. Sorry, guys. Sorry, guys.
I
Let's zoom in.
can just screenshot this. Are you okay with
Yeah, take a picture of that.
this one?
Yeah.
Okay.
Mm-hmm.
And do you ever do anything?
I would reduce it. I would use IAA. You could use Pepsin. I have the Pepsin instructions right up here, handwritten.
Okay.
Pepsin's good too. Do a time course with Pepsin though, because it cuts crazy fast.
Oh.
It'll nuke it.
Oh, okay.
So I would do like a 15-minute time point, maybe.
Okay. Do shorter time.
Pepsin kind of sucks, to tell you the truth. Like, you can do it, but the problem is it doesn't cut really specifically unless you're like a really super low pH.
I see. So do you do it with like formic acid or?
Yeah, I usually do like 1 or 2% formic acid.
Okay.
Yeah, or TFA. You can put a little TFA in there. It doesn't cause a lot of problems. Like, I'll put in 0.1% TFA
Okay.
sometimes.
Thank
This
you.
is the protocol we're talking about, guys. So this is in solution digestion protocol. If you're a synthetic chemist and you have tons of protein because you made it recombinantly, might as well start high. So 0.2 mg per mil is typically where I start. 50 microliters of protein, and 50 millimolar ammonium bicarbonate or another digestion buffer, but it's going to desalt on column. So as long as it's neutral pH, you're good. That goes out the window though. If you're going to be doing it with pepsin, then you got to be low pH. So it depends what your protein's happy in. The reason people typically do pepsin is because their protein doesn't like neutral pH. So if your stuff's active at neutral pH,
Yeah, it's fine at like 7.4.
Yeah, so I would just digest it with pepsin to start. You could also do a theoretical digest, right? Like, take what your amino acid sequence should be and send it through. I usually use peptide mass or peptide cutter on Ecstasy, and you can just do a theoretical digest.
Will that help me with if I'm seeing miscleavage though with the tab?
You want to make sure that the region, like since you're trying to do an N-terminal region, you want to make sure that the N-terminal region, you get a good cut. Like, you don't want it to be too big of a fragment, right? So, like, make sure that you get, like, I've had people do a project before, and there's no cleavage sites for trypsin for, like, 13 kilodaltons of their N-terminus, right? And so, it doesn't cut it at all. And so, they did a great job. They digested it, they mapped it, and then they found out that their N-terminal fragment is enormous, and they've learned nothing. And so I would make sure you can get, like, as far as BNY sequencing goes, I'd say like maybe 2K is like the biggest peptide we can get good full sequencing on.
Okay.
And so try to make sure, and then you don't want it to be too small either. Like, you don't want there to be a cleavage site and it's like a dipeptide at the end, right?
Yeah.
And so you want a nice size peptide. 4 or 5 amino acids out to maybe like 10 to 15 amino acids. And so try to choose a protease that gives you a cleavage site for the area you're interested in that's kind of optimal in peptide size. The problem with pepsin is pepsin usually like cuts so much that it, like you gotta...
It just makes a huge mess of everything.
Yeah, it's hard to figure out what is what.
Okay.
Yeah. So trypsin's the way to go. But I would do it in silico digest first and make sure it's the way to go.
Gotcha.
Yeah, solve everything in silico before you do it for real. And then you know what you're looking for too, which is great.
Right.
You can do your entire project in a computer before you do your project. And then it'll be really easy for data analysis. So anyways, then you're starting out here. Okay, so you're starting out here, you're in ammonium bicarb. So I like to reduce. I think even if the protein doesn't have disulfides, I reduce it.
Mine does.
Yeah, so just reduce it.
Okay.
20 microliters of DTT from the freezer stock on the container in the freezer, and then 20 microliters of IAA from the freezer stock. So this is 20 minutes at ADC, 60 minutes in the dark. The DTT IAA, you can see they'll like cyclize themselves out, and so you don't have to worry about removing the salt. They should stop reacting on their own.
Oh, nice.
And then you're going to add 10 microliters or 1 to 20 protein ratio for trypsin. So typically, I'm making up my trypsin all at a set concentration. Like my trypsin is always frozen. Where does it say it? Yeah.
100 nanograms.
Yeah, I think I have it on the freezer door, maybe over here. Yeah, so trypsin is it 50 nanograms per microliter, right? I typically go 1 to 20, so 1/20th the amount of trypsin to protein.
Okay.
And some people do 1 to 100, but I just like to destroy it. And then since you're already in ammonium bicarbonate, right? It should be fine. You can just add it directly, but I store my trypsin in 5 millimolar acetic acid, so it has to be activated. Okay, so the DTT and IAA are on the freezer door.
Oh, nice.
If it's not made up for you, so there should be IAA right here and DTT right here.
Okay.
And so if it's not made up, like if the undergrad hasn't made up tubes, then it's 15 mg per mil for DTT and 18 mg per mil for IAA.
Okay.
And I just dissolve them in the 50 millimolar ammonium bicarbonate. And typically there's 50 millimolar ammonium bicarbonate over here somewhere. One of these tubes. But yeah, when you come over to do it, we can make it up fresh.
Okay.
I typically have...
I should be able to...
I have 1 molar here. So
Okay.
typically I'll just take the 1 molar and I'll dilute it right before I use it.
Yeah, that's fine.
And so it's like good. And then, yeah, and so you could try to do the project by MALDI. I would do that too.
Yeah.
Yeah.
That would be very, very new for me. I don't think I've ever...
When you have a digested protein, you can run on the QTOF, but like, come find me and I'll help you do it by MALDI.
Okay.
MALDI's sometimes like really nice.
Okay.
Yeah, but we could do it. Have you run them intact on the Zevo? Do you know that there's a mutation?
I have intact on the Zevo, yeah.
And there's a mass shift. It's not what it's expected.
It's a little bit smaller than what it should be.
Okay.
By like 2 or 2 or 3 kilodaltons.
Okay.
Yeah.
But it's one thing, or is it multiple things? Is it one peak, or are there proteoforms? We can go look at
There's
it.
a couple peaks, unfortunately.
Okay.
Yeah.
Okay. All right. Well, we'll see how it maps. Yeah. Yeah. Getting both MALDI and Zevo data could be helpful.
Okay.
The MALDI's nice because MALDI singly charges all the peptides. You know, when you run the QTOF, you got both time to deal with.
Yes.
So you have to find all the peaks in the chromatogram.
Right.
And you have multiply charged data. So everything's kind of needs to be deconvolved and so forth. The MALDI fingerprint all the peaks all at once in one fingerprint of data, all singly charged. And so it's really nice to map it sometimes, because if you say you map it to the main form, let's say you have like multiple proteoforms all sitting on top of each other, right?
Yeah.
And you map it to the main form, then you know all the peptides that you don't have to worry about anymore, right? And so you're like, okay, well, why don't I know what that guy is? And you're like, okay, well, that guy is right next to a guy I do know what it is, and it's shifted by 4 Daltons. And that's what my intact mass shift is. I'm like, okay, then I know that I want, like, I can't figure out who 15 kilodaltons is, or 1500 is, and he looks like he should be the guy. So then when you go over to the QTOF data, you're like, okay, let's try to figure out who that peptide is.
I see.
And so sometimes it's good to have, like, the map from the MALDI to kind of guide you in the decision.
Okay.
Yeah. And at this concentration, you can just dilute it around MALDI too. Or run it for out of the Ziva method.
Alrighty, thank you.
Yeah. I'll order more chips today.
Okay. You said next week, probably?
Yeah, let's do next week. I'm back full time next week, so I can help you more. Yeah.
Welcome back.
Yeah. All right, so you guys are good. You have plates.
Yeah, sounds good.
All right, and you're chatting about polymers.
Yeah. Chatting about polymers.
If there's any way to get it working, this guy's going to be the one who's doing polymers. Yeah, you're going to be good. All right, see ya. Yeah, you guys are trained. You good?
Yeah.
Do it again right now, and then you'll be like, you'll remember it.
Okay.
And feel free to have me look over your shoulder. I'd rather you not break the instrument.
Oh, sure. Can I
But-
kind of patch the THF?
Totally.
With my stuff?
Yeah, you know what some people do too, since you have another tube? Sometimes people put literally matrix. People will dry mill polymers in matrix. And then take some of that dry milled powder and put it into some THF, even if it's not soluble, and then just put it onto the plate. But you can try all sorts of really crazy stuff. Yeah.
Okay.
As long as it dries and it doesn't look like the chunks are going to physically fall off the plate and go into the instrument, then you're good to try.
Wonderful.
Okay, the other advice I give people. Okay, if you're trying 100 things, because you're going all out and you're like, oh man, I'm going to try everything. Write it down. One of them's going to work. And then you're going to forget what it was. And then you're going to spend months trying to figure out how you got it working again.
Okay.
I've seen that happen far too often. People get something working and they have no idea how the hell they did it.
That sounds painful.
Yeah.
All right. Thank you, Ben.
Yep. Hey.
Zevo's pissed off.
I know. I was coming over this next.
Okay.
I'm on live stream though, guys. Here we go. I'm live streaming it the whole morning. I also got to remember to pick up my kids from school. So your samples are already in the queue. And I'll just, okay. All right, Ziva's unhappy. Missing vial in wrong position. Classic. Who did it die on here? So it was missing vial in wrong position on my samples. E1. Oh. I think it was me. I was the one who did it. I messed up the whole instrument for everybody. Alright, so we're on the Zevo QTOF now, guys. You know, it's a busy day in the world of mass spec, guys. We're going to flip it around so you can see what's going on. The instrument is paused with stuff in the queue. Look who made the mistake. It was me trying to run my Rockstar Focus. I told him it was in plate E1. It's in D1. And this is a robot. And so the robot couldn't find the plate position because clearly it's not there. So to fix this error, you're going to want to restart the entire inlet stack. Then you're going to want to come over to the console. And I'm going to delete the one that's wrong from the queue. It's lame because I wanted to look at that data today. Okay, so once the console is open, you're going to want to come over to the sample manager, which has the error, and reset the sample manager. I take this moment to check the bottles. Everyone seems happy. Everyone's good. Instrument looks good. All right. So once you reset the sample manager, the error should clear, but I typically like to reset the communications to the whole stack again, just in case something is off in comms. Then the Zevo is on, so we shouldn't have to worry about that. And then we're going to load the method that's supposed to run next. I don't think it ran any of her stuff either. And so that's good. Now we're going to load this method here. And now we should see stuff. And we're seeing stuff. And so now I'm going to unpause it. And then now it should start these. And then I'm going to change my sample, because that's the one that messed up, to the correct position. Now we don't get a look at the Rockstar focus. I'm trying to find the lion's mane mushroom in the focus data here. And we'll change the name on that. And we'll change the name on this. And we will resubmit mine into the queue. And let's check and make sure the instrument is running. Does seem to be doing the injection. It's drawing the sample. That means it's working again. And typically wait for it to start actually working and seeing data. QSM. That's a good sound. Injection running. We should have data acquiring, which we do. And so everything should be working now. It positions 1E5, 1E5, A8, and E1. So we're all good. All right. Everything's back to normal and good. All right, guys. Fun live stream this morning. Thanks for tuning in. And, well, actually, are you guys going to use the Bruker? Did you find the plate that was in there? I had it hidden?
Uh-huh.
Okay. Did you already load it?
Yeah, I loaded it.
I'm gonna flip it around because I've been showing Bruker MALDI training all day. But now this is the Bruker.
This is a big ol'.
This is one of our users that actually uses the Bruker on her own here. It's impressive. I think this thing looks like kind of like a space laser cannon.
It's one of my favorite things to show people.
It's a super cool looking instrument. And everything on it is currently working, even though it's just limping along.
Hey, it's doing the job.
It's doing the job. That's how it is. Everything needs to limp along and just keep doing its job. Anyway, so this is what the interface looks like on this one here. And then we're going to look at polymers on here as well. It's been a polymer day. But anyways, guys, I'm going to... Uh-oh.
They didn't like it.
What do we do? Oh, all right. Well, errors on errors today. All right. Let me get off the live stream here. Thanks, guys. It was fun. It's been an hour, you know.
Yeah, that'll do.
I think that's enough.
That'll do for a